Welcome to the second of our lectures on the history of the computer. This series is based on a documentary titled The Machine That Changed the World, 1992. It was written and directed by Nancy Lind and produced by WGBH Television of Boston, Massachusetts, and the British Broadcasting Corporation. Backers included the Association for Computing Machinery, the National Science Foundation, and the Unisys Corporation. In our first lecture, which was also based on the first episode of The Machine That Changed the World documentary entitled Giant Brains, we were introduced to Charles Babbage and his difference engine. We also learned of Babbage's second design, the analytical engine, which was the first computer with a stored program, which used punch cards to input instructions. As we noted, today Charles Babbage is considered to be the father of the computer. We also learned about Ada, Countess of Lovelace, who is known as the world's first computer programmer. Not much happened for the next 100 years until this man, Konrad Zuse, who was a civil engineering student at the time, decided to build a machine that would do complex mathematical calculations needed by engineers. Here you see his first attempt to build such a machine. This is a shot of the machine as it looked in his parents' living room. Unlike the mechanical machines that Charles Babbage designed, Konrad Zuse was building an electronic computer. If Babbage is considered to be the father of the computer, I would suggest that perhaps Konrad Zuse could be considered the father of the electronic computer. Here's a more recent picture of Konrad Zuse, and you'll hear him speak in the Giant Brains video himself. He is credited with implementing several innovative ideas with his project. He was the first to use binary to represent data in a computer. So how did Zuse propose to represent the zeros and ones in his computer? Initially, he used telephone relay switches, mechanical devices, to represent the on and off states of the 1 and 0 of binary code. When the switch was closed, it was in the on state, which represented the 1 of binary, and when it was open, the off state, or the 0, was represented. Then a friend of Zuse's, Helmut Schreier, suggested that he use vacuum tubes instead of those mechanical switches. That's Mr. Schreier on the right. That was a monumental suggestion because by eliminating the mechanical movement of that relay and replacing it with a change in the flow of electrons in vacuum tubes to represent the binary, the speed of the machine was increased, according to Zuse, by 1,000 times. The machine Konrad Zuse was building at the time was the Z1. Now, Konrad Zuse may have been the first, but he was not the only one trying to build a computer around the time of World War II. In the United States, partially due to President Roosevelt's Lend-Lease plan, the country had moved into full-scale, wide-open manufacturing of war materials for those who would soon become our allies. Notice the artillery weapons here. The problem was that in order to fire one of these things, one had to use tables to adjust the angle of the gun in order to hit a target. These guns may have been firing at targets miles away that they couldn't even see. Even if they could see them, if you pointed the barrel right at a distant target, gravity would kick in and the round would be buried in the ground long before it ever got there. Therefore, they needed tables with trajectory calculations for a variety of different types of ammunition and different distances to the target. So they needed firing tables. Unfortunately, the calculations necessary to create those firing tables with all those trajectories would require many, many hours of work on the part of the human computer of the day. The result was a bunch of brand new weapons that couldn't be used. So the Department of the Army commissioned a team at the University of Pennsylvania in the Moore School of Engineering to build an electronic computer. These two men were the engineers who were selected to direct the project. J. Presper Eckert on the left, who I believe was a graduate student at the time, and John Mauchly, his supervising engineering professor. The machine they were to build would eventually be called the Eniac, E-N-I-A-C, or Electronic Numerical Integrator and Computer. We have a few more images. This is J. Presper Eckert, who you will actually see interviewed also in the Giant Brains video. This is a photo of the two engineers with one of their military contacts, and this is John Mauchly. Next, we'll see an image of the actual Eniac computer itself. This was a project for the United States Army to build an electronic device to calculate those firing tables. Eniac had approximately 18,000 vacuum tubes. With that many vacuum tubes, which generated a lot of heat and burned out quickly, they didn't expect that machine to run more than a few minutes before failing. Then the time necessary to figure out which tube failed made the idea impractical. Because of this, Eckert and Mauchly built their machine with vacuum tubes mounted in modules, responsible for a specific job. When it could not complete the job because the module had failed, they simply pulled the module out, plugged in a replacement module, and then sent the old one back to the shop for repair. Another thing to consider about the Eniac was that it had no programming language. In order to change the programming for a different weapon, it was necessary to flip switches or even do some rewiring. Here is another image of the Eniac. You may not realize this, but the smartphone that you have in your purse or pocket has more power than this entire room full of equipment. So in summary, this lecture introduced us to Konrad Zuse and his Z1 computer. Zuse was the first to use vacuum tubes and binary. In the U.S., J. Presper Eckert and John Mauchly head up a team at the Moore School of Engineering at the University of Pennsylvania to build America's first computer, the Eniac. Unfortunately, the Eniac was not completed in time to help with the war effort, but it was used extensively for other applications until around 1954. Okay, so let's take another break. Look over your notes, and when you're ready, come on back for the third lecture in this series on the Giant Brains video of the documentary, The Machine That Changed the World.